Good morning, Steel Academy grades 9 through 11. We're going to continue with our EOC review. One of the big things you're going to have to do on the EOC, I anticipate at least 2 questions of this, is Punnett Squares. You're going to be able to tell dominant, recessive, heterozygous, homozygous traits, everything involved with the genetics of that. To remind you, we talked about it briefly, but a great guy named Gregor Mendel, he studied in pea plants. Unfortunately, we didn't get a chance to do any of the experiments with the pea plants this year. Well, so far. We'll see if we come back to school. But that's still up in the air. Anyway, we are going to get started with Punnett Squares. So, to remind you of something, 2 vocab words you might have, and pardon my cough, don't worry, it's not corona. It's just allergies, weather changing back and forth. But heterozygous. So when we're looking at the genes of someone, a lot of times they'll get passed on the genes, one from each parent, and the gene is either dominant or recessive. So a heterozygous person has 1 dominant, 1 recessive gene, and a homozygous person has either 2 dominants or 2 recessives. What's unique, and you call that homozygous dominant or homozygous recessive. What's really unique about this, a heterozygous person is going to show the dominant gene. We'll talk about that tomorrow. That's called the phenotype. The phenotype. That's easy to remember because physical and pheno both start with PH, even though it sounds like an F. Homozygous recessive actually show the recessive trait, and homozygous dominant show the dominant trait. So you have to be homozygous recessive to be able to show the phenotype of that recessive gene. That's why you see a lot more people not have the recessive phenotypes than the dominant phenotypes. So we'll hop right into the Punnett square crosses. What we have up here, I already went and did the crosses for you here. Hopefully you understand what it is because we did this in class. But up top, we have a heterozygous. I put T for tall. I just pretended tall is a dominant trait, so I put uppercase T for the dominant trait, lowercase t for the recessive trait. Over here, someone who is homozygous recessive. And you can see, even though they're out of these 4 different genes that go in, only one of them is dominant. But when you come and look at it, you still have 2 people would show the phenotype of a tall person, 2 people would show a short phenotype. However, these 2 would be called a carrier because they are heterozygous. So they carry that recessive trait. You come on over here. You see we have 2 homozygous people. Homozygous dominant and homozygous recessive. And actually all of them turn out to be the same thing. So if you've ever heard of a doctor saying, well, yeah, if you have kids, they'll look like this, or they they should have this or this or this, that's just genetics. Over here, we have 2 heterozygous. These 2 heterozygous end up with 1 homozygous dominant, 1 homozygous recessive, and 2 heterozygous. So even though in this one, the phenotype wouldn't show in either of them, both people would be tall, since uppercase T is tall, you still have one ended up with homozygous recessive because they were both carriers. So end the video real quick, something fun. You can be funny with this. You can be serious. Go ahead, send it to my email or go ahead and comment on this. Make sure we keep it appropriate. But from daily observation, what would you guess is a recessive trait in humans? What would you see less of in humans? What would you guess is a recessive trait? Go ahead, answer that. If you answer that, I'll give you a couple bonus points. Figure I miss giving away bonus points since we're out of school, so give me a good answer, I'll get you some bonus points. Make me laugh, I'll make you even more bonus points. Once again, let's keep it appropriate. But good job today, guys. And thank you for coming.